Hi, so I'm here again with my latest creation. It's a current meter. So basically I have my house and I need to measure the power that I consume regularly, and I have the current transformer which is inside, and I have plugged it very nicely and neatly, and this is the final signal which comes down through this coaxial cable, and it comes down through this audio jack. So this is the board. So as you can see, this board has the major controller, which is microchip 18F4520, the crystal 20 megahertz, and 4 deep ICs 8 pin. The first one is a programmable gain amplifier, and the programmable gain amplifier from microchip MSP6S21. The reason why do I need a programmable gain amplifier is because the current that some of the low level like tube light fan, they are very less, in the range of about 50 to 70 watts, but some of the high end like the toaster or water heater, they consume almost 2 kilowatts. So I need a programmable gain amplifier so that I can measure both the signal accurately. Then I have this is the op-amp LM358, and it is configured to act as a full wave precision rectifier. So basically the signal that I get over this current transformer is AC, and I convert it to DC, and since the signal level is very low, I need a precision rectifier. Then I have this EEPROM. Then I have this RTC which is DS1307 from Maxim. I also have this UART connection, which is connected through this UART to USB, and it is connected to my laptop. And other than that, I have also my power supply. It's a cute box that I made some time back for giving 5 volts output. And also I have this modem. It's a GSM modem. This is the SIM card, and this is the modem, and this is the antenna, pink wire. The basic idea is that once I am done with my project, so I'll interface the serial port to this modem, and so I can know the power consumption in my house through my mobile, through SMS or something like that. Yeah. So this LCD. So basically the figure, the values what we see in this LCD are the current in 3 form. One is average value of current, the RMS value of the current, and the peak value of current. Now why do we need all three is that for some kind of load like our laptop adapter and tube light, the fluorescent lamp, the power supply is not sinusoidal, the current drawn, so the peak value is much higher, whereas the RMS and average value are not very high. Whereas for geyser and such kind of resistive load, the RMS value also becomes high, and because the current is almost sinusoidal. So so these are the 3 value of current, and I have this. You can see the value of time and date, which is displayed from RTC. It's real time, and the EEPROM address. So currently it is saving at 392, and it saves new data every 5 seconds. So it has gone to 393, and if you wait for another 5 seconds, through 394. So currently, and it can go up to 64K. Yeah. So what I'll do right now is switch on the device, and I will show you the output. So off, on. So some initial, it does some self test on EEPROM, yet success. On RTC it does some self test, that's also a success. It does a test on programmable gain amplifier. So right now the current consumption in my house is very low. So you can see the average value and RMS value are very low. The peak value is slightly higher, because of some noise or something. So what I'll do is, for demo purpose, I'll request my wife to switch on one of the fluorescent lamp, and let's see how does it increase. Bedroom call karna. So so you can see the average and RMS value have gone up, and as well the peak value has gone up. Yeah, kitchen ka. So that's the second fluorescent lamp then you're switching on. Yeah, so you can see it's almost double. Earlier it was almost 7 and now it has gone to 14, the RMS value, same with the peak value. Okay, now the third one, which is from the another room, I'm switching it on. Let's see how does it increase. Yeah, increase, switch it on. Yeah, it's almost 21, so it is going in the multiple of 7, so it's quite linear, you know. For each 7 increase in the RMS value, we can say that it's one tube light which is working in my room, the computer room. So the fourth fluorescent lamp, we are switching it on, and let's see how does it increase. Yeah, it is going to again 7 increase, so that's again perfectly linear. So for a step change, we will switch on the biggest load possible in my house, which is a 2 kilowatt water heater. Just switch on the water heater. Yes. Okay. Yeah. So you can see that's a huge increase in you know, the current drawn. Everything has gone up. And if you notice very carefully, my EEPROM address currently it is showing as 426. So that's the address where it is saving right now. This is the demo as of now. What I'll do right now is take the data out of my EEPROM and put it in the PC so that I can do some analysis. Okay, so this is the software, the terminal emulator I'm using to download the data from my EEPROM. What I'll do is, yeah, one more thing, my laptop is not running on power supply, it's running on the battery, so basically I'm not drawing any current from my line. So for dumping, the code I have used is DMP and everything is caps, so I'll press caps DMP, so it is dumped. So that's a big set of number. So if you notice very carefully, the last number is 451 and the same is here over here, so 452. So it shows the dump is from the first value to till the last value, whatever is shown, whatever is there in my EEPROM. So what I will do is I'll make an Excel plot of this and let's see how does it work out. So I have imported the data into Excel, and this is the curve that I get. So you know, we can have the data, we have current which is lower over this range, and this goes very low, and then this is the time when we switched on the geyser in the water heater. Now these data are from a time when I was not recording the video. Actually this is the point from where I'm recording the video. So you can see the value is very low, and for each switch on off switch, when we switched on each of the fluorescent lamps, so the load has gone in steps. So it has gone up to 1, 2, 3, 4 fluorescent lamp we switched on, and then suddenly we had the water heater which is 2 kilowatt, so it's the same level almost. So, and then again we switched off all the fluorescent lamp and the geyser, and so it has come almost to 0. So it's very simple that we can monitor the power consumed in my house. And as I said earlier, in future I'm planning to interface it with a GSM modem, so that I can remotely monitor the power consumption in my house. Now one more thing I forgot to mention is the value that is shown in the LCD for each current is not, they are not the they are not amps, they are not current value as such in physical parameter. We need to scale it, but that I'll do it later. One more feature that I forgot to mention is that if I have to reset my EEPROM, so how do I do it is I have another command that in my code. So basically I'll have to type caps. You notice it, my EEPROM is actually running currently at 511. So I will try to reset it and let's see how does it go. The value I'm entering is through ERS, so I'll type ERS. So let's see. Yeah, it has come to 32. So 32 is the starting address what I have used in my software, and it works perfectly. If you still like it, paste me a comment. Thanks a lot.